Hello, good evening to you all. And today, actually, my the discussion of my point will be uh, on radiology, and the concern of the topic will be radiophysics only, and the chapter will be on radioactivity and gamma rays, which is actually very important, and often it is asked in the exam. Now, definition of first of all, you should know the definition of radioactivity and the radioactive disintegration and radioactive equilibrium with nuclear transformation, with nuclear reaction, production of radioisotopes and radio pharmaceuticals. These are very important topics which often it is asked in the exam, and in the university exam, particularly in the for the final year for the PGTs, it is very important. Now, as the radioactivity, we all knows that the Henry Becquerel discovered the nuclear phenomenon of the radioactivity, and he left some uranium salt wrapped in a black paper on the photographic plate, which was lying in the dark room, and which he developed after photographic plate, and found that the plate was affected. And after repeating the experiment with other salts of uranium, he concluded that uranium and its salts emit incredible radiation which can pass through the paper, wood and glass, and affect photographic plate, and above radiations were found to be have alpha, beta particles and gamma radiations. So thus he discovered the radioactivity. And radioactivity, now the definition is the process by which the nucleus undergo disintegration and emits either alpha or beta gamma radiations, which the radioactive process atoms changes an atomic number to chemical identity. This is the very important, and an atom with the unstable nuclei and perform radioactivity is known as radioisotope. So if it is a radioisotope, it means that it has the potential for performing radioactivity. And if it is not performing radioactivity, then it is normal, that it is not a radioisotope, it's simple isotope. So initial atom undergoes disintegration, is known as the parent, end product is known as daughter. A radioactivity, now the classification of radioactivity, you should know, is classified as natural radioactivity and artificial radioactivity. Now the phenomenon spontaneous emission of rays such as alpha, beta and gamma heavy elements having atomic number more than 82 is known as the natural radioactivity, like radium. Like radium 226 is known as natural radioactivity. Natural radioactivity. Now, artificial or induced radioactivity was discovered by the Curie and Jollet, and when they were studying the disintegration of light elements by particle, and boron, aluminum, they bombarded with alpha particles, and unstable nucleus was found, and which was disgregated spontaneously. And artificial radioactive elements emits electrons, neutrons, protons and gamma rays, and they follow the same decay law of the natural radioactivity, like cobalt 60. So here the main discussion point would be that the main question, and if the question is being asked about the radioactivity, and you should be able to write that the radioisotopes are natural isotopes which are more than 82, and which are less than 82, they are natural they are artificial radioactivity. Like radium 226 is known as natural radioactivity, and cobalt 60 is known as that is known as artificial. So this is the difference between radioactivity, natural and artificial. Now we will discuss something about nuclear force and stability. Now, if a nucleus wants to be stable, now it should overcome the repulsive forces between the protons, and stability of the nucleus requires certain combination of the protons and neutrons, and this means that the neutrons should be higher than protons. So NP ratio must be higher. So if the neutron would be high, then the NP ratio must be high. So NP ratio is not linear for all elements on increasing order. So if you see the graph between the relation between the proton and neutron, you will see not a linear graph, but you will see a sigmoidal, not sigmoidal, you will see an increasing graph, and it tells that the NP ratio is always increasing. The law of atomic number elements, that is Z less than 20, are known as the lighter element, which are stable and have NP ratio equal to 1. Now in this number, the protons is equal to number of electrons, and the element with Z equal to 20. Z you must be knowing, as I told in earlier video, Z means the atomic number. So Z equal to 20 to 82 is known as the heavy elements, and atomic number increases, neutrons are more in number, and NP ratio more than 1, leading to the nuclear stability. Now the elements having Z more than 82, as just now we have discussed, are said to be unstable nuclei. When it is said to be unstable nuclei, it is known as the radioactive isotopes, and the majority of them are naturally radioactive. So radioactive means that it is a radioisotope. So the neutron increases as Z increases. Above all, atom requires NP ratio about 1.5 stability. Hence unstable nuclei performs the radioactivity and attain the stability. Now it is also found that greater proportion of nuclei are stable, whom proton and neutron with 7 number, which is said to be even nuclei, and lower proportion of nuclei are unstable when they have Z and odd n or odd Z and even n. So however, only 4 nuclei are stable in odd in number. So you have to remember the radioactive. Here the main concept is about remembering the radioactivity and which are the radioisotopes and what is Z number, when the Z increases, when decreases, what are the natural, what are the artificial radioisotopes, that you have to remember. Now we are coming something which is known as the radioactive disintegration. Now radioactive disintegration is very important to know, and it was discovered by the Rutherford and Soddy, and he found that at which the radioactive material disintegrate was independent of the physical and chemical condition. Their law states the number of atoms disintegrate in unit of time that is proportional to the number of radioactive atoms present in the instant. Now, for example, there is a mathematical sentence which is given that let n be the number of atoms. If the n is the number of atoms present in the given time t, and the differentiation is dn atoms, then if we disintegrate in the time dt, then minus dn by dt is directly proportional to n. Okay, or dn or dt is lambda n, where lambda is a constant which is known as the decay constant or disintegration constant. Now this is very important. So if it is asked that what is disintegration constant, you tell with example, then the mathematical sentence you have to give is this. And it is characteristic by radionuclide, and decay constant refers to the fraction of remaining atoms in a sample that decays per unit time, and unit is second to the power minus 1. So this is the definition of disintegration constant. Now the above equation estimates an average rate of decay of radioisotopes, and the decay rate may be due to statistical fluctuation. A radionuclide may perform multiple decay mode, that is branching, and each model has its own lambda value. Lambda, as I told you, what is lambda? It is also known as the decay constant or disintegration constant, and such nucleotide is the total decay constant equal to sum of the decay constant of each decay mode, and each specific decay mode is defined as branching ratio of it is lambda 1 to lambda, where lambda 1 is the ith mode of decay constant. The minus sign indicates that n is disintegrating with time, and after integration the above differential equation is n equal to n0 e to the power minus delta t. So this is actually, just you have to remember it, and you have to write when the radioactivity definition is being given as a long answer question, and where n0 is the initial number of atoms and e to the power kt is the decay factor that refers to the fraction of radioactive atoms remaining the time t, and it is exponential function, and e is the base natural logarithm, that is e equal to 2.27 e equal to 2.719, and if lambda time is very small, then approximated decay factor is 1 minus lambda t, The equation shows that the number of atoms of a given radioactive element decreases exponentially with the time and approaches to zero in a linear graph. So if we see the linear graph, it will be approaches to zero, and if it is drawn on a semi-log paper and the straight line graph, from the graph it is found that disintegration takes place at a much rapid rate initially. With gradual increase of the time, it decreases and reaches zero. So theoretically, as an infinite time is required to disintegrate all atoms. This is the main actually function of the disintegration, and you have to remember that how radioactivity takes place and the disintegration constant and the various mathematical sentence and the graph. So this is the main in a gist which I have told you. Now we are discussing something about the half-life and the mean half-life period. So half-life you have to remember, because each radioisotopes, or if it is not a radioisotope, it is a plain isotope, or if the radioactivity is not taking place, it has also half-life. So half-life you have to remember, and half-life is the radioactive, it is defined as the radioactive element defined as the time taken for half of the initial number of atoms to disintegrate. And from the law of radioactive disintegration, the fundamental decay equation, N is equal to N E to the power, just a second, it is E to the power lambda KT. So if T, that is if the half-life T half is half-life, then the T small t is T half, and N equal to N0 by 2, substituting in the above equation. So if we substitute the above equation, N0 by 2 equal to N0 e to the power lambda T half, and if we integrate N0 by 2 by half-life, then N0 by 2 becomes half equal to E lambda KT half, which is equal to 2, that is which is equal to E lambda T half, and log 2 equal to lambda half, or T half is equal to log 2 by lambda, and the value of the log 2 is 6.93 divided by lambda. So this is actually the half-life and the mean half-life period which you have to know. So this is the mathematical expression. You can this expression you will get in your textbook also, and this you have to remember, the half-life and the mean half-life. So the half-life of the radioactive element is inversely, now the thing is, the main theory portion is the half-life of a radioactive element is inversely proportional to the decay constant of that element. Okay, now the half-life element is inversely proportional to the decay constant of the time. It is seen that after 1/2 period, activity is reduced to half value, and after 2 half-life period, it is 1 by 2 to the power 2 value, and after the n life period, activity is equal to 1 by 2n value. And half-life values of some of the important, now I will be giving you some of the important radioisotopes which is used in our medicine, like half-life of the few radioisotopes like radium 226, and it is half-life is 1622. I think you have already know this. Cesium 137, it is 30 years. Cobalt 60, 5.26 years. Iridium, it is 73.8 years. Iodine, it is 60 years. Strontium, 28.9. Phosphorus 32 is 14.6. Iodine 131 is 8.04. Lutetium 177 is 6.64 days. Samarium 153 is 1.93 days. Technetium 99M, very useful, it is 6 hours, and gallium 68 is 68 minutes. So these are some of the radioisotopes which have been given the half-life. So you have to remember the mathematical sentences, and how the half-life is produced, and how the half-life is inversely proportional, and how the half-life is being derived. Now I have just, because this chapter is long, so I have just given you up to this only. You try to remember this, and if you have any problem, just you ask me in the video itself, or in my group, or in my WhatsApp. So I am in the next. This is actually the part 1 part of in the radioactivity and gamma rays. In the next part, I will be discussing with you the activity and the effective half-life and the specific activity and some of the numericals, which are very important, a radio and radioactive equilibrium. And after that, nuclear transformation, alpha decay and the properties, etc., that I will be discussing. Because since it is a long chapter, so it will require a concept, and just if you don't become concept, then if you don't actually know the concept, you cannot solve and you cannot answer the question. So better would be I will be continuing in the next part, and the next part I will be giving you within 1 or 2 days. Until then, you just listen with what I have told, and you try to see that in your textbook of your radiophysics, you will understand. And if you have any doubt, you can ask me easily. Thanks a lot.